Hello, thank you so much for tuning into my YouTube channel. In today's video, I want to talk about the basic points I wish I knew when I first started coding in Python. I was a MATLAB user back in the time, and when I first switched to Python, it was very hard for me to adjust to it, and I wish I knew these basic points that I'm about to share with you guys. Let's get started and see what they are. As I said in this video, I want to talk about the basic points I wish I knew when I first started coding in Python. The first one is OpenCV IMShow size limit. To be more specific, in OpenCV there is no specific size limit for displaying an image using OpenCV IMShow function. The size of the image that can be displayed largely depends on your system's display capabilities and available memory. OpenCV's IMShow function will attempt to display the image within the bounds of your screen and available resources. However, very large images may not display properly or may be downscaled to fit within the available screen space. If you try to display an image that is much larger than your display resolution, you may only see a portion of the image and you might have to scroll or resize the window to view it entirely. It's a good practice to resize images to a reasonable size before displaying them using IMShow in OpenCV to ensure they can be viewed comfortably on your screen. You can use OpenCV's image manipulation functions to resize images as needed. Let me show you what I mean in Python. Okay, here I have two images. This is the smaller image and this is the bigger image. I'm reading it using OpenCV, then I'm going to show the image using OpenCV, and then I'm going to show the bigger image. Let's first run this part. This is the image. So this is the size of the smaller image that you're seeing right now. It's 910 by 670 by 3, which is the number of channels. Let's show you guys the bigger image. This is the bigger image. See, you can't see the whole thing. There's no way you could see it. So the size of the bigger image is 3640 by 2680, much bigger than the smaller image. So you have to be cautious with the size of your image when you want to show them using OpenCV. The next point is counting starts with 0 in Python and with 1 in MATLAB. When you transfer images between Python and MATLAB, be cautious as Python starts counting with 0, but MATLAB starts with 1. For example, I had synthesized this rectangle with a yellow box inside a while back in MATLAB. I wanted to use this rectangle in Python to do some object detection in which the yellow box inside is detected. The size and position of it is detected. The size of the box is going to be the same when you transfer this image from MATLAB to Python, but its coordinates are not going to be the same, and you have to subtract 1 from its original coordinates in MATLAB. In other words, if this is the coordinates of the rectangle and this is the script that I used to synthesize that rectangle, let me first run it. This is MATLAB. So this is the coordinate of this rectangle, 50 and 60. When you save this image and you want to use it in Python, you have to make sure to subtract 1 from this data, from the coordinates. But width and length, of course, is going to be the same. But when it comes to coordinate, as I said, you have to subtract it from 1. So overall, you have to be careful when you transfer files between MATLAB and Python, as the starting point for Python is 0, but for MATLAB is 1. I think Anaconda Python is the best Python platform, especially for the former MATLAB users. Anaconda comes with its own package manager called Conda, which makes it easy to install, update, and manage Python packages and libraries. Anaconda includes a wide range of pre-installed data science and scientific computing packages such as NumPy, SciPy, Pandas, Matplotlib, Jupyter, and so on. This can be very convenient for users in these domains as they don't need to install these packages separately. And also, Anaconda is available for multiple operating systems, including Windows, Mac, and Linux. Another reason that I could think of is Anaconda allows you to create and manage isolated Conda environments, which are self-contained environments that can have their own Python version and packages. Moreover, Anaconda has a large and active community, which means you can find support tutorial and resources easily. And lastly, it is especially suitable for ex-MATLAB users as the environment of Anaconda resembles MATLAB a lot, and it makes it pretty intuitive for MATLAB users to use Anaconda Python. The next point I wish I knew is the difference between the star and matrix multiplication in Python. Star is the element-wise multiplication, and to do the regular matrix multiplication, you need to use NumPy matrix multiplication. Let me show you what I mean. So here are two matrices. They're all 1. I first show you what's the result of the regular matrix multiplication using this NumPy matrix multiplication, and then I'm going to show you what happens when I use star. So you could see that the result of matrix multiplication is 3. All the elements are going to turn into 3, and the results of using star is all 1. So you could see that the result of a regular matrix multiplication in which we use NumPy matrix multiplication is not the same as using star, in which an element-wise multiplication is performed. The last point that I would like to mention is OpenCV and its default color space, or CV2 instead of OpenCV. The default color space of OpenCV is BGR. This problem shows up especially when you use a different library for reading the image than OpenCV, such as SkiImage, and then you use OpenCV to save the image in your system, such as OpenCV IamWrite. When you do that, SkiImage loads the image as RGB, but OpenCV assumes the image to be BGR, because BGR is the default OpenCV color format. This means that blue and red planes get flipped. You can solve this problem using two approaches. The first approach, assuming you want to still use SkiImage to read and OpenCV to write, is to use OpenCV CVT color to convert from RGB to BGR. The second way is to use OpenCV IamRead to load the image. In this case, we're working only with BGR images. Let me show you what I mean in Python. I'm going to be loading the image. As you can see, this is where the image is located. I'm going to be loading the image using SkiImage, and then I'm going to be saving it using OpenCV. I'm going to be saving it first using this converting function, and then I'm going to be saving it without the conversion. So sample not color corrected, but this one is color corrected. And then in the second one, I'm just going to be using OpenCV to load and then save the image in the same folder. So sample ready in OpenCV. Let's see what happens. Okay, these are the images. This is the original one. This is sample color corrected. You could see that it matches the original image. But this one right here, as you can see, is not color corrected. The colors have flipped. So I loaded the image using SkiImage, and then I saved it using OpenCV without color correcting it, like this one. So the color is not correct. And then with this one, everything is correct because I used OpenCV to both load and save the image. And that's about it. Thank you so much for watching this video. I hope you liked it and you were able to get something out of it. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.